For over 50 years, we thought we had the story of our universe pretty much figured out. It all started 13.8 billion years ago with the Big Bang. From there, the story was simple. The universe expanded, it cooled, and then, very slowly, over hundreds of millions of years, the first primitive galaxies started to form. It was a clear timeline that has defined our place in the cosmos. But the James Webb Space Telescope has done it again. It has sent back an image that's beginning to rewrite the rules. Staring back at us from the very dawn of time is a galaxy. A galaxy so massive, so bright, and so well formed that, according to everything we thought we knew, it just shouldn't be there. Its very existence suggests the starting gun for our universe might have gone off much, much sooner than we ever thought. So how is this impossible galaxy real? And what does it mean for the foundational theory of our universe? Today, we're unpacking the evidence that could force us to rewrite the very first chapter of cosmic history. To understand why this is such a big deal, we need to talk about why the James Webb Space Telescope was built. Its giant golden mirror was engineered for one primary purpose: to capture the faint, ancient light from the cosmic dawn, the period just a few 100 million years after the Big Bang. Before JWST, our models gave us a clear picture of what we expected to find there. We were looking for cosmic seedlings, small, messy, and chaotic proto-galaxies. They were supposed to be faint, low mass, and made of just hydrogen and helium, the universe's primordial ingredients. But that's not what JWST found. As astronomers on the JADES team processed the data, they found something that defied all expectations. It's a galaxy now known as JADES GSZ 140. This isn't just any galaxy. It holds the record for the most distant galaxy ever confirmed. We're seeing it as it was when the universe was less than 300 million years old, just 2% of its current age. To put that in perspective, if the entire 13.8 billion year history of the universe was a single year, the Big Bang is January 1st. The light from this galaxy left on January 8th. And what a galaxy it is. It's shockingly bright. So bright, in fact, that it implies the galaxy is already packed with several 100 million times the mass of our Sun. It stretches over 1,600 light-years across. This is not the tiny seedling astronomers were expecting. As one astrophysicist put it, it is like finding an adolescent where you would only expect babies. The discovery left scientists stunned. Stefano Carniani, a lead author on the discovery paper, said it plainly. It is stunning that the universe can make such a galaxy in only 300 million years. The existence of JADES GSZ 140 isn't just a record breaker. It directly challenges the timeline we've held for decades. How could something so developed exist so early? Does this discovery challenge our cosmological models? In a word, yes. The problem isn't that the Big Bang didn't happen. The evidence for an expanding universe is overwhelming. It's not that our models are wrong, but they're incomplete. Our current understanding, the standard model of cosmology, is called lambda CDM. It's been incredibly successful, but JWST is revealing cracks in the theory. The first major issue is the speed. Lambda CDM predicts that galaxies form in a slow, bottom-up process. Small clumps of dark matter pull in gas, which slowly forms stars and small galaxies. Over billions of years, these smaller structures merge to build the massive galaxies we see today. JADES GSZ 140 throws a wrench in that timeline. For a galaxy of its size to exist just 290 million years after the Big Bang, that process must have been far more rapid than our models allow. As one professor noted about similar early findings, if the masses are correct, we are in uncharted territory. The mysteries don't stop there. The second piece of the puzzle is its chemical fingerprint. When astronomers used JWST and the ALMA telescope to analyze the galaxy's light, they found the unmistakable signature of oxygen and dust. In astronomy, any element heavier than hydrogen and helium is a metal. These metals are only forged in the hearts of stars and are released when those stars die. Finding oxygen in a galaxy this ancient is a profound shock. It implies that a full generation of massive stars had to form, live, die, and explode, seeding the galaxy with heavy elements. Then, a new generation of stars had to form from that material, and that's what we're seeing now. All of this in less than 300 million years. According to our current understanding, there just wasn't enough time. The presence of oxygen means this galaxy isn't just forming, it's already chemically mature. That's not what we expected. JWST isn't just finding more galaxies, it's finding galaxies that are far too mature, far too quickly. For a galaxy like Jade's GSZ14-0 to exist, star formation had to be running in complete overdrive, something that's at the absolute edge of what we thought was theoretically possible. So if the standard model is struggling to explain these quote-unquote impossible galaxies, what comes next? And that's where things get really exciting. This discovery doesn't give us an answer, it just opens the door to a flood of new questions and some radical new ideas. The first, most conservative idea is that our models of galaxy formation are simply incomplete. We are, after all, looking into this era for the very first time. Maybe the first stars, these hypothetical population 3 stars made of pure hydrogen and helium, were far more massive and lived much shorter, more violent lives than we predicted. They could have seeded the universe with heavy elements much faster, jump-starting galaxy formation. Scientists are now scrambling to tweak their simulations to see if they can grow a galaxy like Jade's GSZ14-0. A second, more speculative idea challenges the very ingredients of the universe. What if the seeds of galaxies weren't just tiny, random fluctuations? Some theories propose that primordial black holes, formed moments after the Big Bang, could have acted as gravitational anchors. These massive seeds would gather matter at an accelerated rate, allowing galaxies to skip the slow, bottom-up growth process. It's an intriguing possibility. And finally, these discoveries are forcing us to ask the biggest questions. While they don't disprove the Big Bang, they are causing some scientists to revisit alternative theories. Ideas that suggest gravity itself might behave differently on galactic scales could explain how galaxies form so fast, but these theories have their own set of problems to solve. What's clear is that the early universe wasn't a quiet, slow-moving place. It was a chaotic, vibrant furnace, building huge, complex structures with incredible speed. The cosmic dawn wasn't the gentle sunrise we imagined. It was an explosive fireworks display. What do you guys think? Are our models just missing a key ingredient, or is this the start of a revolution in cosmology? Let me know by dropping in your comments below. The story of Jade's GSZ14-0 is the story of science working exactly as it should. JWST was built to push the boundaries of our knowledge, and it has succeeded beyond anyone's wildest dreams by presenting us with something that, by our current understanding, shouldn't exist. This isn't a failure. It's the heart of the scientific process. Our theories are just maps. And when you explore a new place and find the map no longer matches the terrain, you don't give up on the journey, you draw a new map. Jade's GSZ14-0 is forcing cosmologists back to the drawing board. They aren't closing the book on the Big Bang, but they're proving that the first chapter needs a serious rewrite. The universe, it turns out, was far more creative in its infancy than we ever gave it credit for. And we are just now beginning to read its true and far more exciting origin story.